going to continue working with radicals, and we're going to talk about rationalizing the denominator. It's a method used to eliminate radicals from the denominator of a fraction. Just understand that radicals are not okay to have in the denominator. You have to simplify. So, for example, when we have a quotient, which is basically a fraction, what we know is if I have a quotient or a radical of 49 over 4, that's like taking radical 49 over radical 4. So I can separate that radical into a top and a bottom. So this first example we need to simplify. It's radical 10 over radical 3. So here's what we do. To rationalize the denominator, we multiply a radical by itself. Here's why. If I have radical 2 times another radical 2, that becomes radical 4, which is the whole number 2. Do you see how when I multiply a radical by itself, it eliminates the radical completely and it just leaves you with what's inside? You can try it with some others if you'd like. Take radical 3 times radical 3, take radical 4 times radical 4 if you're not understanding. So if I want to get rid of this radical 3, I'm going to multiply it by radical 3. But here's the thing. I have to multiply both the numerator and the denominator by the same thing, since it is a fraction. So when I simplify, I have radical 30 over 3, because this would be radical 9, which simplifies to 3. Now this is simplified because there is no perfect square factor that I can fit inside here. I can't take 30 divided by 4. I can't take 30 divided by 9. And 3 obviously is not in a radical, so that is fine. Let's try another example here. How do I get rid of this in the denominator? Multiply it by itself. So I multiply by radical 15, radical 15. And so in the denominator, you know you're going to have 15 because radical 15 times radical 15 is 15. So then in the numerator, I do 35 times 15, and I get radical 525. Now, we know that we cannot take radical 525. It's not a perfect square. So I have to think of the greatest perfect square that can fit inside there. And I know you might be thinking of 25. If I do 525 divided by 25, I get 21. And I think that would work out really nicely because there is no perfect square inside radical 21. So let's simplify this. 5 radical 21 over 15. Now we are not done. Do you see how outside the radical I have a 5 and I have a 15? Those can both be divided by 5. So I divide the 5 by 5 and I divide the 15 by 5 and I get radical 21 over 3. Now you try an example just like these two in your notes. Now what if I have a variable involved? Does that change anything? No, it doesn't. I'm going to get rid of this radical 8 in the denominator by multiplying by radical 8. So then I have radical 56x, all of that is inside the radical, over 8. And then you think about 56. Is there any perfect square factor that I can divide into 56? No, so we're completely simplified. Now, I want to show you one other thing you could do. Do you see how radical 8 is not simplified? Do you see how it is a perfect square could be factored out here? You could factor first if you wanted to and make this radical 4 radical 2, which would be 2 radical 2. If you wanted to, you could do that. Now the top would just stay radical 7x for right now. And then if you wanted to, then you could rationalize it here and then just multiply by a radical 2 if you wanted to. And that might be a little bit easier for you. And so it's kind of up to you what you want to do. Ooh, and when I do this, I see maybe there is a perfect square factor we could get out of there. So let's look and see. So that's radical 14x over, this is going to be 2 times radical 2 times radical 2. These are going to simplify to 2. So that would be 4 in the denominator. So let's see if we can take 56 divided by something. And maybe some of you already did. And you were saying, hey, Mrs. A, and yelling through the screen. We can take this divided by 4. Radical 4, radical 14x. So this 14 is completely simplified. So that would be 2 radical 14x over 8. I can take 2 divided by 2. I can take 8 divided by 2. So that leaves me radical 14x over 4. And so there are two different ways that you could simplify when that denominator is in a radical form. You could simplify first, then rationalize, or you can rationalize first, then simplify. It's up to you. Let's try this example. We have radical 2 over radical 6. So we're going to go ahead and rationalize first because that can't be simplified. And we have radical 12 over 6, because this is radical 6 times radical 6. And then you think of 12, I can divide that by 4, and 4 times 3 gives me 12. So that would be 2 radical 3 over 6. Do 2 and 6 share anything? Yes, they do share a 2, so divide by 2, and you get radical 3 over 3. So try an example like these in your notes now. Now, we're going to go on to conjugates. I really want you to pay attention to this section, and if you need to re-watch it, please do. A conjugate is a binomial of the form a radical b plus c radical d and a radical b minus c radical d. So you have radical plus radical, and then you have the same radical minus the same radical. And this will fit back into a couple chapters ago when we were doing our factoring of a difference of square. So for example, 3 plus radical 2 and 3 minus radical 2 are conjugates of each other because it's the same first number, the same radical, and it's just a difference in a sum. So those are what we call conjugates. And what happens then when we multiply them is it's a difference of squares. So it would be first term squared, which is 9, minus last term squared, which would be 2. And what works out great is it simplifies into a whole number. That would be 7. So in this case, if you wanted to use boxes to check it, you could have 3 radical 2 and 3 minus radical 2, and you can multiply all those boxes to check it, and what you'd notice is those diagonals would cancel out. And that's how you get 9 minus 2, which is 7. So let me show you how you would solve these. Do you see how this is a sum, 5 plus radical 2? So what we're going to do is we're going to use the conjugate, because I can't just multiply by radical 2. Let me show you what happens. If I multiply by radical 2, like you simplified in the last example, radical 2 would have to be distributed. So it would be 5 radical 2 plus 2. Did I eliminate radical? No, I just moved it. So that's why we have to use a conjugate, because we have a sum. If we use the difference, now we will get rid of the radical in the denominator. Now we'll rationalize it like we wanted to. So in the numerator, I have to distribute this 3. So that would be 3 times 5, which is 15, minus 3 radical 2. So the top is simplified. In the denominator, you're going to do a squared, so 25, minus radical 2 squared, which would be 2, which simplifies to 23. Now look at your 3 numbers that are outside the radical. Do they share a common factor? Well, those 2 do, but 23 doesn't. So you are simplified, that's your solution. Let's try another one together before you do your own. This is a difference, so I can't just multiply by radical 7. I have to multiply by its sum, the conjugate, to get rid of it. Now, the numerator you're going to distribute. So 7 times 3 is 21. 7 times radical 7 is 7 radical 7. In this denominator, we're going to use a squared minus b squared. So 3 squared is 9, minus radical 7 squared is 7, which simplifies to 2. 9 minus 7 is 2. Do these 3 share a common factor? No. You can divide these 2 by 7, but not 2. So because this is all 3 have to share a factor to simplify. You can't simplify because they don't all 3 share a factor. So this is completely simplified. So you try the example of conjugates in your notes.